How many of you have seen this talk before? Anyone? Very few people. Okay, very few people. Perfect. Just a bit about me. I have plenty of time because I've given this talk before in a much shorter slot, so I know I can take a minute. My name is Gonzalo. I work at Booking.com. I live in Amsterdam almost for 2 years now. As you can guess from that XKCD classic, I am, let's say I'm more fond of Lisp than Perl. Like God says at the end, the universe was hacked mostly with Perl. The comment says also, we lost the docs for quantum mechanics. You're going to have to parse the regexes yourselves. So that's how I feel. And I consider myself more of a C and C++ hacker, and of course, a Lisp. Scheme rather than Lisp. But anyway. So, DevelQuickCover. What did we want, or what do we want to achieve with this thing? So the idea is that we can take a Perl program and with little work, a small amount of modifications to it, find the lines that are actually executed in runtime. This is not a code analysis tool, or there's nothing static about this. This is in runtime. We want to find which lines were actually executed, hopefully without a large impact in CPU or memory. Why? Because we want to leave this running for our actual production code, which is the code that gets the most exercise, and that's the code that we really care about. And we would like to find good candidates for dead code, right? And maybe clean it up a bit. So just as inspiration, you can see at the bottom of that little program, there's different lines that could be executed depending on the argument, right? That's an absolute value function. So lines 21, 22, and 23 will be executed depending on whether you passed in a negative, positive, or a zero number as an argument. So that's trivial, and it's kind of contrived, but that's what we're looking for. So, can we do this? Yes, we can. So, to ponder, how could we do this? If you take any program like that one, where you know that not all of the lines will be executed, and you run it through Perl concise, we get a large dump of information. Anyone here not familiar with concise output? Okay, good. So some of the slides are not going to waste. This is giving us the opcode that's being executed for that program we were looking at before. And there's a lot of information here. I'm not going to go into all of it, but if you search for it, you will find that there's a specific piece of information that says next state, and then it has next to it a file name and a line number. And if you look at the original code, you will find that those 3 line numbers, 4, 5, and 8, actually match the lines that will be executed for sure in this program. Now, it doesn't show 6, because 6 will depend on what you passed. Of course, we know it will be executed, but Perl doesn't know until it executes that code. So maybe there's something here. Maybe the information that concise shows is pointing to the way of how to gather this information in runtime. So that takes us to the Perl op tree. I'm going to assume that not everyone here is familiar with the Perl op tree. Again, same file, same example. So this is kind of like basic compiler theory. When you parse programs like that, what you usually get is something close to an abstract syntax tree. Sorry about the English, but difficult words here. Which is a tree representation of the operations in your program. And Perl generates something like that. It's called the op tree, where for each operation in your program, it will select one of a list of several operations that it knows beforehand. You have a few there. It's more than 100. So you see there stuff like fetching a const value. There's others for adding values, etc. And one of those operations in that list is this thing called up next state, which, if you will remember from the concise output, matches the next state in the concise output. So that next state is an operation that Perl generates at the end of each line in your source code that tells it, I'm switching from this line to another line. So that just might work, right? So here we have a possible way to achieve what we want. And from there, we hatch our evil plan, which is create a new XS module where we will hook into the Perl op dispatch table. We will register every time Perl will call the op next state, we will register it somewhere, store that information. And at the end of the program, we will dump all that information that we gathered into somewhere, a file, from which we can profit, whichever way you want to define that. So what do we need to store? It's pretty much 1 bit of information per each file and line in that file. So it shouldn't be that much. But there could be multiple files, right? So a module will use or require other modules, and we want to, well, Perl will generate the next state op for those files as they are being executed as well. So we will have to gather all of those. And we know that there will be many lines per file. So this points to having a hash of files, and for each one of those files, a bit set indicating which lines are being executed. So with that structure, we can quickly set a given bit when that line was actually executed, and we don't actually care about other theoretical set data structure operations. So that's how we will use it. So, and we truly end up using 1 bit per line as memory. So what could possibly go wrong here? We might be wrong, and there actually will be a heavy load on the CPU while we have this module running. We might actually be using a lot of memory to gather the information, and the whole thing could go down in flames. So we, of course, need to test this and be careful. So this is the oh shit moment, live demos. So I have a bit of a more, it's useless, but it's a more real life example there. It's a program that will, for every argument that you pass it on the command line, it will count how many of its arguments are pure lowercase, pure uppercase, mixed case, numbers, or any other combination. And if this still works, yeah, well, not there. So we have 8 words that are pure lowercase, 1 that's mixed case, which is Gonzo, and 1 other, which is the 30 with the comma, which the shell passes as a single argument. Okay, so that works, and DevelQuickCover generates output files into the TMP directory, so I just want to show you that we don't have nothing there. We don't have nothing because the use of DevelQuickCover is commented out. So let's activate it. Let's rerun. So we still get the same output, which is awesome. And now we have a file in there. What do we have inside the file? It's JSON. and blah, blah, blah. We have some metadata, the date and the time the file was created. We could put some stuff in there. I will tell you what we use that for. And then we have a hash of files. So for each of them, we have the name, and then a set of array refs, arrays, this is JSON. And this list here is the covered lines. Covered means those lines were actually executed. So you will notice here that we have line 13 was executed because we did have words in lowercase. Line 16 was not executed. We didn't have any words in pure uppercase. Then 19 was executed because we did have mixed case. Numbers, line 22, not. There were none. And the others, case 24, was executed. So we're actually gathering the information we wanted. That's real. So the thing works. We don't know if it will break anything yet, but it actually works for that case. Wow, a live demo that didn't explode. So how is it done? As I said, this is an XS module, so now we have to look at some C code. It's actually surprisingly little C code. What I'm going to show you is not going to be more than maybe 15 or 20 lines of code. The real module has more lines because it has to generate JSON and it has to manage the files in TMP and create them in a way that you don't overwrite a file that was already created and blah, blah, blah. Still, we could take a look at that, at how many lines. I would guess it's between 1 and 200 lines of code. So it's actually a very small piece of code. So remember I talked about all the ops that Perl knows, over 100. So what Perl has is a static array indexed by the op, where it stores the handler for that op. So when it's walking the tree and it finds its op xxx, it takes the op xxx as a constant and indexes into the array, and the array is a pointer to a function that will execute for that op, and then the function does its magic. So what we do when we install the module is take the current value for the op next state and store it in our own static variable, which is there called next state original. And then we put our own function, QC next state, into that dispatch table. And what that function does is over there. First thing it does is call the original function, so that whenever our next state is called, the first thing we do is call the original function, because you don't actually know and you don't want to know what the original next state handler does. You just know that you have to run it so that Perl will not go nuts, right? And store the result that returns. And then we call our own little thing and then return the original result. So what is our own little thing? We call a function that receives the file name and the line number, and that's it. I'm not going to show the details of what the function does, but it's what I just said, right? It gathers this information in a bit set in memory, and then it's ready to dump it at the end of the file. There's a grayed out area there that will be clear later when I mention a couple of improvements we've done to this code. So, improvements. How we have changed the code after that initial implementation, which worked. So this is not a profiler, so we are not really interested in how many times we actually go over one line. We are just interested in the fact that we did go over it. So we don't care if it is the 10th or the millionth time we execute a line. We just want to know the first time we go over it. Therefore, one improvement we can do is that after we call that our own next state handler, we restore the original handler for that particular line. Therefore, every subsequent execution of that line will just call the original Perl handler, and we will not be having any impact. So this is very relevant for loops, right? How do we do that? Remember, that's the code, as I showed you, and that's the little gray area. What we do there is, the first time we go in, we restore what we had stored in our original handler. So for that particular line, this code will not be called anymore. Then, when we're executing a file, we are not going to hit all of its lines. But some of those lines are not hit because they are comments, so they will never be hit. Some of those lines are not hit because at that particular run, they will not be covered. So this is an improvement where we use the peephole optimizer to determine what are the possible lines that could actually be executed. And we actually store them in a different bitmap so that we can then, when we present our reports, the report will show more clearly, yeah, this line is never going to be executed because it's a comment. And this line could have been executed, but it was not in this particular run. So now we're using more memory, 2 bits per line. And the other improvement is that, this was Steven's idea. There's more than one execution time, so we have several phases. Those are the internal names that Perl uses, but this is basically a begin block, right? So we may want to know when a line was executed inside a begin block or not, or keep tags differently for those. So we now need more bits per line, but we store more information. And in fact, if you look at the output here, those were the cover lines. These are the present lines, the lines that could have been executed. So you see that 16 here, which was not actually covered, is included in the present lines. And this is the phases information with lots of additional information. So that's what we're gathering now. So we know it works. Can we dogfood it? And does it have any actual impact? And the good news is that, yes, we can. We're using this in one of our web environments, a pretty heavily used one. There's zero impact on startup time, so we don't do practically anything at startup. So just using the module doesn't do anything. I'm sorry. No impact on the web startup time. Using the module does have a lot of impact, because when you use the module, from there on, every other use and every other code that's run at compilation time will call our handler. There is an impact in memory usage, which is measured around 100 megabytes for this particular case. 100 megabytes is less than 10% of the actual process size, memory size. So we think it's okay. I forgot to mention there, but there's no impact in execution time at all. So this thing could not be there for all we know. And what we do is we run and we generate many files in the TMP directory, and then we have a cron job running that will collect those files, and it sends it somewhere else where they are aggregated. And we generate reports of many kinds. Originally, we used DevelQuickCover and used its reports. Now we're generating our own. So we have that metadata that I mentioned that you saw in the file. We put in there, for instance, the Git tag that's associated to that deployment. So with that, we can know if we're looking at a file that was recently changed. And if not, we show the report for the file for as long as we have evidence that it has not been changed. So this is very useful for files that don't change that much and that show lines that are not actually being executed. Those are the good candidates for code removal, right? Dead code. So that's an example of the report we get. The number doesn't really mean anything. The green numbers mean those lines were executed. You will notice there that this is proof that the YAPC branch of that if was never executed, which is lovely. And that's it. Use it. And we are using it, and it's been really helpful. We have removed quite a bit of dead code, and the people there were either inspiration or they helped with ideas, code, or encouragement. Questions?
In your first example, you showed a source file with a continuation line.
Yes.
And your coverage only showed, or your algorithm only showed the first of those two lines, but you neatly lined them both.
Yes.
Will you detect the situation?
No, so the layout of the code will not be faithfully represented in the coverage information. So if you have like an if with this and that and that and that, and you split that into 10 lines, you will only get one line in the coverage information. And it's very difficult because what you would have to do is some code, source code analysis to know, oh, this line here actually means the whole 10 lines. So we are not doing that.
Another question. Will you be able to detect that you are not actually using the modules you use?
So you mean you use module X, but then you don't call any function in the X module? Right. Yeah, so what will happen there is that you will have, we generate, so at some point we were generating reports for every function, every module or file that was actually included in the cover files. I believe the reports we have now, since we have the Git tags and everything, it's actually, we go to the Git repo and we say, these are all my files. Oh, and for these files, I don't have any information here, so I just paint them all empty. And so then, yes, you would find that that you are not using. Now, this is, we are using this in a large application, so it may happen that one module uses X, or it has use X and doesn't use any actual functions, and then another module uses X and does use the functions, and in that case, we will not know, right? We will not know that the first one is not actually using the module. So it's coarse-grained, I guess. And again, it's not a data profiler. It's just a look at the dynamic aggregation of what code you're actually running in production. Over there. Yeah, so as you can guess from my disclaimer at the beginning, I am not really a Perl hacker. So I just provided the module, and there's a lot of much smarter people Booking that are doing all kinds of stuff with this. I believe we are doing something like that, but couldn't really tell you. Right, so while you're running, so this is more related to the way we run things. So we use Black and micro WSGI, and in the way that runs is that the workers are killed regularly. Every time one of the workers dies, we dump the files. The files are dumped in a way that they are atomically renamed at the end. So the cron job that's looking for files only gets full files after they have been completely dumped. So anything that's in flight will be either in memory in your process, or it will be in the process of being done, but will not be picked up. Anyone else? Okay, thank you.